Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to do electrolysis problem number 2, which is the reverse of question number 1, which we did in a previous video. We're going to start over here on grams of substance, and we're going to work our way backwards to either figure out current or time. So this is kind of like what the problem looks like. If you want to pause the video and copy this down so that you can refer to it, that might be a good idea, or try it on your own, and when you come back, we'll be working on the problem. Okay, so if we look at this problem setup, it's saying, hey, okay, we're going to make 1.5 grams of sodium, and we want to know how long the time will take if we hook it up to something that has a current of 7.5 amps. So we're figuring out the time, we have the current, and we have how much substance is going to be produced. It's 1.50 grams of sodium. Okay, and those are our givens, and we're going to use this information and do our electrolysis problem number 2. So we're going to start out with this given, and we're going to work our way backwards. So I'm going to start with 1.50 grams of sodium, and the first thing I'm going to do is I'm going to convert that grams of sodium into moles of sodium. Okay, so grams of sodium into moles of sodium, and I'm going to use the molar mass in order to convert that. And I look on the periodic table and I find out that there's 23 grams for every mole. So that gets me from here to here. The next, I'm going to go from moles of the substance to moles of electrons. Okay, so I'm going to go from moles of sodium to moles of electrons. So I need an equation that has moles of sodium and moles of electrons, and that's going to be this reduction reaction. And it's the coefficients are 2 for the sodium and 2 for the electrons. So it's a 2-to-2 ratio. So it really doesn't do anything, because when you multiply by 2 and divide by 2, it really doesn't do anything. Okay? And then I'm going to go from moles of electrons to charge. So moles of electrons to charge, and that charge is always in the unit of coulombs, and we're using Faraday's constant in order to do that conversion. And that says that there's 96,485 units of charge, or coulombs of charge, for every 1 mole of electrons. So I'm going to take my 1.5 divided by 23 times 2 divided by 2 times 96,485, and I get a total charge of 6,292.5 coulombs of charge. So I'm kind of like right here as far as the boxes. Okay, well, I'm going to use that charge, which is equal to Q, with this equation and the amps. And remember, amps is kind of like coulombs per second. Okay, and I'm going to use that to figure out the time. So what I'm going to do is I'm going to rearrange this equation. Okay, I'm going to switch the time, and that's going to equal to Q over the current. The charge being 6,292.5 coulombs divided by the current, which is 7.50. And remember, that's coulombs per second. You can see where the coulombs are going to cancel out, and you're going to be left with seconds. And if you divide these two numbers, you'll get the value of 839 seconds. And that's going to be our answer. Okay, so if we wanted to perform electrolysis and make 1.50 grams of sodium, and we apply a 7.5 current to it, it's going to take 839 seconds in order to produce that 1.5 grams of sodium. So this is just another electrolysis problem, but instead of starting with current and time and getting to your mass of substance or your grams of your substance, we're going to start out with the grams of substance and work our way backwards to find charge. And then when we have the charge, we're going to use this equation. We use the charge and the current in order to figure out the time. If you found this content helpful, please give it a like and subscribe. And when you add that comment, it really does push this information out to other students that might be interested in learning chemistry.